Okay, section 1.6. We're going to continue with our differentiation techniques, but now we're going to talk about the product and quotient rules. If you remember from section 1.5, we did the sum and difference rules, and those were really nice because it just said that you could take a derivative of each individual piece and then add or subtract them together as necessary. And I did tell you that it doesn't work for multiplication and division. That's because there are specific rules for how to actually do derivatives of multiplication and division problems. So our objectives here are going to be to differentiate using the product and quotient rule, use the quotient rule to differentiate the average cost, revenue, and profit functions. So there will be some more business application for us. And then vocabulary, again, product rule, quotient rule, average cost, average revenue, average profit, and how all that fits together. Okay, so in this section, we're going to figure out how to differentiate things that look like the f of x function, which is a multiplication of two functions, and the g of x function, which is the division of two functions. So like I said before, it'd be really nice if we could just take the derivative of each part and then multiply the results, or take the derivative and then divide. It doesn't, unfortunately, work like that. So there are a couple of formulas that you're going to need, and you are going to have to be able to use these formulas. So the product rule says that if I have f of x, or capital F of x, which is the product of two functions, we're going to say lowercase f of x times g of x, the product rule is written like this. Now, I write it slightly differently than the book, but it works either way. And there's a reason that I do it this way. I will try and explain that to you when we get to the quotient rule. But I write it as f prime of x. So you take the derivative of that first function, and then you multiply that by the second function, g of x. Not its derivative, just the second function. But then you add the derivative of that second function, and then you multiply that by the first function. So it's the derivative of the first one times the second one, plus the derivative of the second one times the first one. Okay, that is the way that the product rule works. So let's go ahead and take a look at a couple examples. It's really not horribly difficult to deal with, but you do have to remember how to do it. Okay, so the nice thing is it says here, don't simplify. So we don't have to do all the extra algebra at the end. So in letter A, our derivative of capital F there is going to be the derivative of the first piece, the derivative of x to the fourth minus 2x cubed minus 7. So again, we take that piece by piece. The derivative of that is going to be 4x cubed minus 6x squared, and the derivative of 7 is 0, so we don't have to worry about that one, times the second one. Not its derivative, just times the second one. Plus product rule. Now we take the derivative of the second function, the derivative of 3x squared minus 5x, which is going to be 6x minus 5, and then we multiply that by the first function in its original form. And that's it. That's the derivative using the product rule. So once again, it is the derivative of the first, so this is basically your f prime, times the second one, that's your g, plus the derivative of the second one, that's your g prime, and then times the first one, that's your f. So if we label these as little f and little g, that should help see what we're doing. Okay, let's go ahead and do letter B. So the derivative of capital G of x here is going to be g prime of x. So we do the derivative of the first function. The derivative of the first parentheses is 2x plus 4 times the second parentheses, which is 7x cubed minus square root of x, plus. Now we take the derivative of the second parentheses. The first one, we can use the simple power rule, which is 21x squared minus Now that's the square root of x, which remember is the same as x to the 1/2 power, so its derivative is 1/2 x to the negative 1/2. And then we're going to multiply that by the first function, which was x squared plus 4x minus 11. And again, we don't need to do anything else to simplify because it tells us not to. Okay, go ahead and look at this box down here at the bottom of your paper. Error prevention, again, make sure you're not taking the derivative of each individual piece and then trying to multiply those together. That's the first part there that says that's a common error, and it is. Make sure you're actually using the product rule. So you can look through that and just make sure that you're seeing what's going on there. I'm not going to walk through the error prevention with you guys, but definitely take a look at that. Okay. So now let's go ahead and take a look at the quotient rule. Quotient meaning division. So we have two functions being divided by each other. So the quotient rule works very much like the, the product rule in the fact that I'm actually going to change this. I understand why it's got the n and the d there, and your book very well might use that. I'm just going to rewrite up my quotient as f of x over g of x. So we're going to say that that's what that is right there. So q prime is going to be the derivative of f times g, and then the derivative of g times f. Now you might hopefully look at that and say, well, wait a minute, we just did that. That's the product rule. Yes, except the product rule is adding, this is subtracting. If you remember one, you should remember the other because they are exactly the same order. There is one additional piece to the quotient rule. All of that is over the square of the denominator. So we still have to square the denominator. Now you could do this with the n's and the g's. I'm sorry, the n's and the d's for numerator and denominator. N would just be in the place of f, and d would be in the place of the g function. Identical, it doesn't matter. So there's a little rhyme that's down here, low d high minus high d low over the square of what's below. I've actually never heard it in that specific form before. I've heard it as low d high minus high d low all over the square of the low. Same idea. I just remember it's the derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Any of those ways work, whatever works for you. You just have to know that that's the formula and that that's how you use it. So let's go ahead and do a couple practice problems. Letter A. Want to find the derivative of f of x, which is 1 plus x squared over x cubed plus 1. Okay, so f prime, it is a quotient, so it's the derivative of the top, which is 2x, times the bottom, x cubed plus 1, minus the derivative of the bottom, which is 3x squared, times the top, 1 plus x squared, all over the denominator squared. And it does not say don't simplify here, but in this case, we are not going to simplify. It is useful to simplify this for further further things that we're going to be able to do in the future. But for now, I'm happy if we just get through the actual derivative. Excuse me. Okay, so let's go ahead and do the same thing for the g function down here. So g prime is, let's see, the derivative of the top, which is 2x minus 3 times the bottom, x minus 1, minus the derivative of the bottom, which is just 1, times the top, which is x squared minus 3x, all over the denominator squared. And again, for right now, we're not going to go ahead and simplify this. We're just going to leave it. That is the derivative using the quotient rule. Once again, we've given you some error prevention. Make sure you're not taking the derivative of the top and the bottom separately and then trying to simplify that. That is incorrect. That, believe it or not, actually has a completely different use for something else, which I don't even think that we touch on in this course, but there is an actual another calculus use for that. So just make sure you're actually doing the quotient rule. And again, look through the error prevention just to make sure you can see what the common mistake is and try not to make that one. Okay, let's go ahead and give it some business application. So a couple of definitions here. The cost, which we're going to call capital C of X, is the cost of producing X items. If that's the case and we want to find the average cost, remember that if you want to find the average of something, you take the total number of something and you divide it by how many there are. So we're going to take the total cost, which is C of X, and we're going to divide it by X items, however many the items there were. That will give you the average cost. Same exact idea for revenue and profit. If you want to find the averages, you're going to take the average revenue, or excuse me, the revenue function, which we call R of X, and divide it by X, which is the total number of items. That'll give you the average revenue, and we'll call profit capital P of X. So if you want to find the average profit, capital P of X over X will give you the average profit. Just a quick reminder here that profit in general is how much money you make, which is your revenue, minus how much money you had to spend, which is your cost. So profit is revenue minus cost. Okay, so let's go ahead and apply that to example 3. So it says, Paulson's greenhouse finds the cost in dollars of growing 100 geraniums is modeled by the cost function 200 plus 100 times the fourth root of X. If the revenue from the sale of X 100 geraniums is modeled by R of X equals 120 plus 90 square root of X, find each of the following. We want to find the average cost, we want to find the average revenue, and we want to find the average profit when X 100 geraniums are grown and sold. So that shouldn't be too hard. We know that the average cost is going to be the cost function divided by X. So the average cost is going to be the cost function, which is 200 plus 100 times the fourth root of X divided by X. That's your average cost. We want to find the average revenue. That's going to be the revenue function divided by X. Then if we want to find the average profit, well, all we're going to do is we're going to take the revenue, or the average revenue, and subtract the average cost. So the average revenue minus the average cost. Now, in this case, both of these fractions are divided by X, so technically they're common fractions already, common denominators. So what we can do is go ahead and combine the numerators. We're going to go ahead and do that in this case, just because this video will be relatively short compared to the other ones. So if we combine this whole thing over one common denominator of X, we're going to get, let's see, I've got a constant of 120, I've got a constant of 200. So 120 minus 200 is minus 80. I have 90 square root of X, but I can't subtract the other one because it's a fourth root. The roots are different, so we can't subtract them. So we're just going to write it as plus 90 square root of X, and then minus 100 fourth root of X, and divide the whole thing by X. And that's your average profit. Okay, in part B, it says we want to find the rate at which the average profit is changing when 300 geraniums have been grown and sold. So when it's asking us for the rate of change, we are talking about a slope. And when we talk about the slope of something, because we want it at a specific value, they're actually telling us here we want it at that value. So it's at one particular point. That's an instantaneous rate of change, which is a derivative. So we need to take the derivative of the average profit function. So we're going to call this average profit function something. Let's just call it f of x. So I'm going to go back up here and I'm going to label this. We're going to call that f of x, just so that we can use proper notation below here. So we're going to say that f prime of x is going to be the derivative. Well, this is a quotient. We can do a quotient rule here. Technically, we don't have to. If you can do some algebra up front, you could divide everything by x, and maybe that's easier for you, but we have a quotient. We just learned the quotient rule. Let's use it. So we're going to take the derivative of the top. The derivative of negative 80 is 0. The derivative of 90 square root of x. Okay, so remember that the square root of x is x to the 1/2. So we bring the 1/2 out and multiply it by 90, which is 45. And then we reduce the 1/2 to negative 1/2 by subtracting 1. And then the last piece on the numerator is the negative 100, so we'll put a minus. 100, then the fourth root of x is x to the 1/4 power. So you might want to rewrite this part right here as 100 x to the 1/4, just so that you can see that. Oops, that's a 1/4 on the top there. Just so you can see that better. Bring the 1/4 out to the front. Wow. Let me rewrite that because that looked like 400. It's supposed to be 100. There you go. Bring the 1/4 out to the front and multiply it by the 100. 100 times a fourth is 25. And then reduce the 1/4 by 1. That's actually going to give you negative 3/4. So there's the derivative of the top times the bottom function, which is just x, minus the derivative of the bottom. The derivative of x is just 1, times the top. So we just rewrite the top function. All over the bottom squared. All right, so now it says we want to actually figure out how the average profit is changing. We just found how the average profit is changing, but we want to find it specifically when we have 300 geraniums. So now we just plug 300 in for x, and we see what we get. So we're going to do f prime of 300, which is going to be 45 times 300 to the negative 1/2 power minus 215 times 300 to the negative 3/4 power. All of that times 300 minus 1 times, I'm not going to write the 1, negative 80 plus 90 square root of 300 minus 100 fourth root of 300 all over 300 squared. And then we're going to have to plug this into the calculator to see what we get. But f prime of 300 is going to be approximately equal to, I am getting negative 0.004. I am not extremely confident that I plugged all that into my calculator correctly. Oh, you know what? I do have something that I need to fix here, only because, and I did plug this part into my calculator right. That's not 215, that's 25. And I think that I wrote it incorrectly in the above line too. That should be right there. Okay. Again, I'm not extremely sure that I plugged all that stuff into my calculator correctly, so just be very, very careful because obviously you can make a very simple mistake. I may have done that, but if that's the case, then that's telling us that when we've sold 300 geraniums, um, the rate of change of the average profit is actually going down by is going down by 0.004. Again, not extremely positive I plugged that in correctly, but that's the idea. All right, should have enough. That's it.